With all the information overload, the overchoice in products, and the more demanding customers, e-commerce platforms are confronted with the problem to provide customers with products and services in an effective, efficient, and personalized way. Automated tools, such as recommender systems, which are capable to recommend the most suitable and useful services or products to individuals in a personalized way, are an excellent solution to such problems. Especially in case of experience goods such as whiskies, which are hard to evaluate before consumption, recommender systems come handy. The dataset we used to create the recommendation system contains 86 different whiskies from Scotland with 12 variables indicating flavor characteristics and 3 variables containing information about latitude, longitude, and postcode. Our research process follows a cluster analysis along a feature selection, provides initial models, finds out the number and sizes of the clusters, the validation of those, and finally comes up with a final model. Based on the flavor features correlation matrix and a filter algorithm, we came up with 2 reduced feature spaces, one without the flavor medicinal and one without fruity, malty, and tobacco. The full feature model is also further analyzed for comparison reasons. Concerning clustering algorithms, we used 3 different ones: k-means and PAM as partitioning procedures and hierarchical agglomerative clustering. To not just analyze one distance measure for these algorithms, but rather contrasting different performances, PAM and HEG are implemented with Euclidean Manhattan distance, respectively Euclidean and Spearman correlation distance. However, for k-means, no such 2 distance measures are applied since the algorithm is already implicitly based on Euclidean distance. For HEG, we also considered the 2 best performing linkage algorithms for both distance measures used, which you can see at the bottom gray box. So overall, we have a set of 21 cases that we further evaluate. With the help of multiple methods and indices, we arrive at a final cluster model which outperforms all the others. K-means with 3 clusters described along 9 flavor features. Since this is not the original feature space, the result strongly indicates the utility that feature selection provides for clustering. The clusters are distinct in terms of their size and the flavor characteristics. The first cluster is the biggest cluster with 42 whiskies. The flavor notes of this whiskey group stand out for being mostly floral and sweet. The second cluster, however, is exactly the opposite of it. It sets itself apart from the others with having rather nutty, winey, and honey flavor notes. The remaining 10 whiskies build the third cluster. This cluster has primarily smoky and medicinal notes. Based on the cluster analysis, we developed a content-based recommender system in the last step. But what does this recommender system tell us in the end? Practically speaking, recommender systems are highly beneficial. These benefits occur for both the consumer and the retailer point of view. Thinking as a consumer, recommender systems can help us find things that we will definitely like by simply inserting what we like already. This saves us a huge amount of time and effort for searching. For the retailer, it might improve sales by giving the customers something to rely on and might even lead to cross-selling. In theory, literature already told us that this content-based recommender system is proven to be a very simple yet effective method, which was confirmed with our research. Of course, these findings are only limited to our study. At the beginning, our cluster tendency showed that our dataset is not able to be clustered perfectly. This issue might have had consequences on our cluster solution. To prevent this in future research, one could start at the very beginning when gathering the data by collecting greater datasets with more observations. When looking at the cluster algorithms, we were only considering hard algorithms. That means those that assign observations exclusively to one cluster. But keeping in mind that we did not have an ideal cluster tendency, one could also take soft clustering methods into account and only assign observations to clusters with a certain probability. We wanted our recommendation system to suggest the most similar whiskey to the initial one as possible. Sadly, this is an issue called overspecialization. Although these are good recommendations, they suffer from not being very original and might as well be whiskies that the user could have found by himself with just a little research. In future studies, this research could therefore be repeated with a more serendipitous and novel approach. Finally, another approach that could be tested in future research is the hybrid recommendation system. It combines the benefits of content-based with a collaborative filtering method and is therefore supposed to even better recommend alternatives. Of course, this method could not be applied with the dataset at hand, since we do not have any information about reviews or ratings, but this is one issue that could be kept in mind when gathering a larger dataset as well.